NASA reveals major new discovery on Mars. What if the secrets to life beyond Earth have been hiding in Martian rocks all along? NASA's Curiosity rover has just uncovered the largest organic molecules ever found on Mars compounds that could be the chemical building blocks of life itself. Could this mean that Mars once supported the kind of chemistry that led to life on Earth? And if so, what does that say about the possibility of life elsewhere in the universe? Stay with us as we break down this groundbreaking discovery, because the answers might change everything we thought we knew about the Red Planet. Scientists working with NASA's Curiosity robot have found the largest organic compounds ever found on Mars. This could change how we think about the possibility of life on Mars. The discovery, which was published in the Proceedings of the National Academy of Sciences, has gotten planetary scientists and astrobiologists very excited. It suggests that the chemistry needed for life may have advanced a lot further on ancient Mars than was thought before. The results came from looking at smaller pieces of rock that Curiosity brought back from a place in Gale Crater called Cumberland, which are organic molecules that are necessary for life on Earth because they help make cell walls and do other important biological jobs. Scientists warn that these chemicals can also be made by geological processes that don't involve living things, but the fact that they are there is still important. It makes it more likely that Mars may have once had the complicated chemical pathways needed to start life. The rock is also full of clay minerals, which form when water is present. It's likely that liquid water has been in Gale Crater for a lot longer than millions of years, according to co-author of the study and senior scientist at NASA's Goddard Space Flight Center, Daniel Glavin. That means there was enough time for chemicals that could have led to life to form in these crater lake environments on Mars. This most recent find was a bit of a surprise. In a different experiment, scientists were looking for amino acids, which are the building blocks of proteins. Instead, they found signs of the bigger organic chemicals. The team found small amounts of decane, undecane, and dodecane after cooking the sample in Sam's oven and studying the gases that came out. Even though these chemicals don't show that there was life on Mars, they strongly suggest that the planet did once have the right conditions for prebiotic chemistry, which is the complex interactions of molecules that happen before living things form. Fatty acids are mostly made by live things on Earth, but they can also be made by things that are not living. These chemicals can be made by reactions between water and minerals in hydrothermal vents, which happen a lot on Earth and probably also on Mars in the past. Scientists worked backwards to figure out where the chemicals in the Cumberland sample came from. They heated undecanoic acid and dirt that looked like it came from Mars in the same way that Sam did. As expected, the experiment created decane, which proved their theory. They also looked at earlier research to make sure that dodecanoic acid and tridecanoic acid could be used to make undecane and dodecane, respectively. Why it's so hard to land on the moon? We did it 50 years ago, after all. Why is landing a spacecraft on the moon so difficult? And given that we accomplished this with Apollo in the 1960s and 1970s, why are we having trouble now? In the wake of the lunar lander Odysseus from Intuitive Machines toppling over after a gentle landing, this is a pretty interesting question that many people have been asking. It's a good question too. I completely agree that it's absurd that landing on the moon is so difficult, given that we were successful doing so 50 years ago. The fact that the mechanics of landing on the moon haven't altered is the main problem here. In general, the moon remains the same, although it has traveled 80 inches distant from us in the past 50 years. The atmosphere of Earth acts as a brake mechanism by nature. The 3 parachutes opened, and the spacecraft made a soft landing in the water after the capsule successfully exited the outer atmosphere. For comparison, Apollo 11 splashed down at likely 10 to 15 miles per hour, 16 to 24 kilometers per hour, after re-entering Earth's atmosphere at nearly 24,000 miles per hour. By contrast, Intuitive Machines had to use only its engines to reduce their spacecraft's speed from 25,000 miles per hour to 6 miles per hour. Additionally, you must bring the fuel with you. Indeed, The moon's gravity is 1/6 that of Earth's, which lessens the drag on the spaceship. But it doesn't really matter at that speed. All you have are engines, and you must slow down. The moon's surface is terrifying. The moon's terrain is likewise chaotic. There aren't any pleasant oceans to splash around in. Rocks, craters, and regolith or lunar dust are the things that end up everywhere. Not to add that the Apollo landing locations, which were in bright sunshine, are a lot different from the lunar South Pole. We believe that the moon's water ice, a significant resource if we choose to live there permanently, is located at the lunar South Pole. But even with less sophisticated technology, we managed to accomplish it half a century ago. What's happening then? We haven't gotten any less intelligent since then. There are some excellent reasons why we struggle now, whereas we used to be able to accomplish it. One significant difference from Apollo is that astronauts are not on board robotic landers to make real-time repairs. For instance, a master alarm was thrown by the guidance computer of the LM lunar module during Apollo 11 as it descended to the moon's surface. Because the rendezvous radar had been left on, the computer was essentially overburdened and unable to concentrate on the tasks required for descent and landing. The computer was unable to interpret the radar updates as well as the descent and landing due to a programming fault. It keeps rebooting and kicking back faults. One thing that really makes you want more? Based on the SAM measurements, it can be said that the fatty acids are longer than those that are usually made by abiotic processes. In non-biological chemistry, chains are usually shorter, with less than 12 carbon atoms. The molecules here, on the other hand, have chains with 11 to 13 carbons. The detection range of SAM isn't great for finding even longer chains. This means that there may be bigger and more complicated organic molecules in the rock that aren't found. What this means for the search for life? This finding makes the case for bringing samples from Mars back to Earth much stronger. There, they can be studied using much more advanced tools than what is on Curiosity right now. We're ready to take the next big step and bring samples from Mars back to our labs to settle the question of whether there is life on Mars, Glavin said. A mission like this is already being planned. The findings of this study contribute to the accumulating body of evidence suggesting that Mars was not always the arid and chilly desert that it is now. There is a possibility that early Mars was very similar to early Earth in many respects. Both consisted of bodies of water that had been there for a considerable amount of time, hydrothermal systems that were active, and a chemical environment that was conducive to the existence of life. A number of philosophical and scientific problems regarding the nature of life and the way it operates in the world are raised as a result of this discovery. When the fundamental chemical components of life are able to form and remain on Mars, the possibility that life could have originated on the planet on its own is becoming more and more plausible. In order to determine how Mars went from being a place where people might be able to live to a place where no one lives, scientists will use the information that they obtain there to conduct their investigation. During this interim period, researchers are continuing to examine the data collected by SAM and other instruments on Curiosity and Perseverance in an effort to discover additional hints. The Mars sample return and possibly even human exploration efforts will undoubtedly benefit from this significant discovery, which will undoubtedly be of assistance to future missions. It is almost clear that scientists have discovered evidence of life that existed on Mars in the past. The discovery of these huge organic molecules serves as a potent reminder that the world may contain more life than we ever imagined it to hold. Subscribe now for more groundbreaking space discoveries and updates from the Red Planet.